Okay, this is question 5 from the 2022 P3 exam. When we read through it all, you can see that it's going to be numerical methods. It's going to be locating roots, followed by, there's a little bit of iteration there, and then the last part is going to be differentiating to find the maximum points. So let's have a quick look at the first part. It says, show that the x-coordinate of P is where it hits, read the question, P is where it hits the axis, Q is where it hits the axis. The P point, show that the interval lies between minus 1.25 and 1.2. So we'll get started with that straight away and just do a quick bit of teaching here, that what they're basically saying is if I'm trying to locate this root here, you don't need this as part of your answer, this is just me explaining what's going on. We have a root, let's actually have it on the right side, over here somewhere. And if I put in minus 1.25, I'm going to end up with a negative value. If I put in minus 1.2, I'm going to end up with a positive value. So if it goes from a negative to a positive in such a short space of time, then it must have cut through the axis, which means there must be a root there. It doesn't actually have to go from negative to positive. It could go from positive to negative, but obviously we've just had a look at the graph so we can see that that's what's happening with this one. Now I don't need any of that, that's just explaining it to you. All we need to do is to work out what those values are. So the question was, y equals 6 log 2x plus 3 minus a half x squared plus 4, and what we're going to do is we're going to work out f of minus 1.25. Okay, so if we're doing that and putting that in, that's going to be 6 log, 2 lots of that is going to be minus 2.5 plus 3 minus a half 1.25 squared plus 4. You don't really need much more than that because we're really interested in answers here. This is a negative value, which is absolutely what I was expecting. I'm now going to do the same thing down here and do f of minus 1.2. So that's 6 log minus 2.4 plus 3 here, plus a half minus 1.2 squared plus 4, and again chuck all that into the calculator and it comes out to be 0.2. Now I'm very fussy about what I write next, so I say, and this really let's write down while I'm talking to you. So since there has been a sign change, and the function is continuous. Sorry, the function is continuous in the interval minus 1.25 to minus 1.2. Therefore, there is a root. And I make all my students write that down. I make them learn basically this passage here for whatever question that we're going to get, and then regurgitate it. You're sort of convincing the examiner that you know what you're doing here. So it's change signs, which means that there must be a root there. There is a possibility, obviously, if we had some sort of asymptote value, that you could still get that happening. So why we say the continuous bit as well. So that's a perfect answer, and that's what I'm going to leave for my one for parts A. So second part, B part 1. I'm not going to keep jumping back up to the question. B part 1 says use the iterative formula. X to the n plus 1 is equal to the square root of, and then whatever it's going to be this time, 12 log x to the n, 2x to the n, 2x to the n plus 3 plus 8 So that's my iterative formula, and it says start off with x1 equals 6. So for part 1, can we find the value of x2? So in order to find the value of x2, hopefully you understand how iterative formulae work. I'm going to put 6 in here, work out my value, and because that's x1, my answer out will be x2. We basically keep repeating the process. Put 6 in, get an answer, put that answer back in, get another new answer, and keep going. In terms of what I'm going to write down for the examiner, x1 equals 6, x2 equals, and I'm going to tell them what I'm doing just for this one pretty much. I don't do, I've got to think about our timings when we're going through and doing this. So 2 lots of 6 here is 12 plus 3 plus 8, and that's more than enough really in terms of showing what I'm actually doing here. You've got to focus on using your calculator and actually getting the answer out. So this works out to be 6.3, sorry, let's get my handwriting sorted out, 3637 there. So fine, that's the answer for B part 1, because it really focuses on can we find the answer for x2. And then for part 2, it just says, by continued iteration, can you give your answer to 4 decimal places? So I'm just going to keep going, doing the iterative formula until up to 4 decimal places, my number doesn't actually change. So I'm not going to spend ages doing that. I'm not going to do that now 4 or 5 more times because it takes too long. So here, in order to get x3, I'm going to be putting that number in, but I'm not saying any more about that. I'm focusing on actually doing this on my calculator and getting that sorted out. So if we put 6.3637 in, we get 6.4081 out. I'm only writing to 4 decimal places, but I'm keeping obviously the number all the way through. When I put that one in, x4 works out to be 6.4134. The whole idea about iterative processes is that it should be narrowing in on a number here as long as it actually converges, which is what this one does. So x5, if I put x4 back in, gives me 6.4141. So the change here is getting less and less as I'm getting further on down the iterative process. And then 6.4142 for x6 is the last time that we have any changes happening in this 4th decimal place here. You can do x7 if you want to. I'm not going to bother. Again, we do have to think about our timing here. I've done it already. I've calculated. I'm not going to write it down is what I mean. So x6, I had to do it that many times, and now the changes in this number are happening more than 4 decimal places down. They will keep changing all the way through, but we're quite happy to have that as being my answer to 4 decimal places. Actually, I was quite surprised how many times I had to do that. So I was happy that it was continually converging on a point, but it's a lot of times to have to do that to get the answer coming out. And then part C asks us, I'll go back and look at it again. Part C actually asks us, can we find the maximum turning point M? Can we find this point up here? And just check, I want the x coordinate. Okay, I want the x coordinate of M, so that's gonna save me a little bit of time. They do that pretty regular, where they'll actually, regularly, should I say, use correct English, pretty regularly, where they ask me to do this process, but they don't want me to then have to sub it back in to find the y value. So hopefully, again, trying to be really clear with the examiner here, I'm going to tell him what I'm doing, him or her, for the maximum value, dy by dx is going to be equal to 0. So what I've got to do is to be able to differentiate my function. Let's remind ourselves of what the function was. Put space there, yeah. Y equals 6 log 2x plus 3 minus a half x squared plus 4. And what I'm going to need to do is to get dy by dx. So just quick reminder of what we do. with logs. If I've got log of some sort of function here, the differential is 1 over the function multiplied by f dash x. Okay, go away and just check that yourselves if you're not sure about that. This is dy by dx. If we're differentiating 1 over x times by the differential, 1 over the function, times by the differential of the function. Okay, get rid of that, that's not part of my answer. So here, dy by dx, I've got the 6, I just ignore 6, it's just a constant. I don't ignore it, but I don't use it as part of my differentiating here. So differentiating 1 over 2x plus 3, sorry, log 2x plus 3 is 1 over 2x plus 3 times by the differential of 2x plus 3, which is 2 here. And now I sort of go back and say, yeah, there was a 6 there originally, I can leave that in there. Differentiating half x squared, multiply by the power, add 1 onto the power. But hopefully you can just see that, that's minus x, and obviously the 4 will go completely. Tidy that up then. dy by dx is 12 over 2x plus 3 minus x, and I'm going to be putting that equal to 0. Okay, let's do that. 12 over 2x plus 3 minus x equals 0. I can see this is going to be a quadratic, but let's just go through and do it. Take the x over to the other side first of all. Is equal to x, and then we want to get rid of that fraction by multiplying everything by 2x plus 3, which means I get 12 equals x. 2x plus 3, which then gives me 2x squared plus 3x on this side equals 12. 2x squared plus 3x minus 12 equals 0. Now, normally with our AS level and our P1, 2, 3, 4, at this sort of stage, I'm trying to see if this factorizes, because a lot of the time they do, even though they don't look like, easily recognizable factorizing ones. The only reason, well, apart from the fact I've done this question already, the only reason that I might be tempted to think it doesn't is because this is a numerical methods iteration type question. But anyway, it doesn't. So we've got to use a quadratic formula on it. So x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. I'm not doing all that. You can do that at your own leisure. We get that working out to be, and even with this one, I'm just going to tell you what I found the answer to be. It worked out to be 1.81. There was a negative answer, but from our diagram, I know that I'm going to take my x value to be a positive number there. Just check back through the question. I was just checking, did it say 2 decimal places? It doesn't say anything there, so I could put any degree of accuracy I want, so 2 decimal places seems to make sense. Okay, hopefully that is all good for you.